Parametric differentiation is actually really easy if you know the rule. So the rule is, if you're trying to find dy by dx, you want to first find dy by dt and then divide that by dx by dt. That's it. As long as you can implement that rule, everything about differentiation remains the same. Now, they're going to make things difficult by introducing trig. They're going to make things difficult by, having extra steps in your question. So it might not be as simple as differentiate this. It might be, okay, work out the tangent to this graph. That's where it might, get a little confusing. But when it comes to just parametric differentiation, this is the rule that you need to know and the rule that you need to apply. So let's have a look at something like this. If you feel like you're ready to do it, give it a shot. Either way, I'm going to go through it. So find the gradient of the point P where t equals 2 on the curve given parametrically by blah, blah, blah. So you want to work out dy by dt. You want to work out dx by dt. It literally doesn't matter which one you do first, provided you do both. So the differential of t squared plus 1 is 2t. The differential of t cubed plus t is 3t squared plus 1. Now dy by dx is dy by dt divided by dx by dt. So 2t over 3t squared plus 1. That's it. That is your differential. You can't simplify that. You leave it there. Now they've told you that t equals 2. So when t equals 2, dy by dx is 4 over 13. So the gradient at P is 4 over 13. That's it. Nice and easy. That being said, have a look at this question. I want you to give that a go, please. Okay. They've given you your parametrics. They've included trig. And on top of that, they've included cosec. So you have to know your differential trig rules. They've also given you the coordinates 2 root 3 and 4 root 3 over 3. Part A says find the value of t at point A. Right. You have the coordinates. You're going to plug those in. Your x coordinate is 2 root 3. So if x equals 2 root 3, then 4 sine t equals 2 root 3. Which means sine t equals 2 root 3 all over 4, which is the same as root 3 over 2. 2 over 4 is 1 over 2. Okay, now you just have to solve that. When you solve that, t equals pi over 3, and using the cast diagram, 2 pi over 3. Okay, when t equals pi over 3, then y equals 2 cosec 2 and then pi over 3, which is the same as 4 over root 3, which is 4 root 3 over 3 after rationalizing the denominator. The reason I've done that is to prove that I've got the y coordinate. So t is pi over 3 at point A. Cool. Part B. The line L is a normal to C at A. Show that the equation of L is blah, blah, blah. Okay, to work out the gradient of the normal, you first have to work out the gradient, and then you have to use the minus reciprocal rule to work out the normal. We have a parametric, so you're going to work out dx by dt first, and then dy by dt. Or, doesn't matter which way around you do it. 4 sine t differentiated is 4 cos t. And then 2 cosec 2t is minus 4 cosec 2t cot 2t. Okay. dy by dx will be dy by dt divided by dx by dt. Like this. Okay. You can divide by the 4s. So minus cosec 2t cot 2t all over cos t. Now, when t equals pi over 3, what does your dy by dx equal? It should equal 4 over 3. When you're plugging something like that in your calculator doesn't have cosec and cot, right? In which case you would use the equivalence. So cosec is 1 over sine, cot is 1 over tan. You would just plug in 1 over sine pi over 3, or 1 over tan pi over 3. Okay? Or in this case, because it's 2, you would times it by 2, so 2 pi over 3. Okay, that's your gradient at pi over 3. So the gradient of the normal would be the minus reciprocal of that, minus 3 over 4. And you have the coordinates. So now you do y minus y1 equals mx minus x1. The whole straight line bit that we went over in pure 1. After doing that, you should get 9x plus 12y minus 34 root 3 equals 0. So after plugging in minus 3 over 4 as m, your x is 2 root 3 and your y is 4 root 3 over 3 as given in the question. Sorry, my 3's look really bad. But yeah, there you go. All you need is the rule. As long as you have the rule, you can do parametric differentiation.